How you going, guys? Curtis from Cutting Edge Engineering. So today's job, we're going to be continuing on with our tool post grinder build. Today we're going to get the motor mounted, sort out the pulley system, and also make the guard to cover up the pulleys. So I'm going to get started with the motor. What I'm going to be using is a Nord 3-phase 3 horsepower motor. I have picked up a few of these over the years, and because it's 3-phase, we will be able to control its speed with a VFD. But because of the spacer I have used to hold everything down while we are testing it, the motor doesn't fit in the correct location, so we will have to make up a custom one of those, but for now we're going to get that out of the way, put the motor in the correct location and mark out our holes. So I am happy with where the motor is sitting. I am going to take a measurement from this face to the center of the bolt hole on the front of the motor. And I can also see I've got about 20mm clearance here for when we make our spacer. And to get the location of the back bolt holes, I'll turn it upside down and measure the centers on the foot mount of the motor. Because the holes on the foot mount of the motor are elongated, we do have a bit of adjustment back and forward. So now we've got our measurements, we can set our tool post grinder mount up in the mill. Now that that's set up, we're going to find our first hole location by using the edge finder. So I'm going to touch off on this face, then I'm going to zero it, then I'm going to move it across 150mm, taking into account the diameter of our edge finder. Now we're going to find the center of the mount by touching off on either side of it and halving it. Now we've zeroed that and we know that our hole centers are 125mm apart. I just need to move across 62.5mm and that will mark our first hole location. Now all I need to do is center drill it. Now I'm going to use a 6.8mm drill and drill 20mm deep. Then we'll countersink it and tap it for an M8 thread. So that's our first hole done. Now we're going to move it 125mm the other way. So with the 2 holes drilled in this location, we're going to move at 140 mil to drill the other 2 holes. So with that drilled and tapped, we're going to take it off the mill, put it back on the lathe and mount the motor. So now with the motor mounted, we can move on to making up the pulley system. To make up the system, we have 2 pulleys. The smaller one is to go on the shaft of the spindle, and the larger one is to go onto the motor. These pulleys are standard off the shelf. They are readily available in many different sizes, and they are cheap. The smaller pulley is a 50 mil diameter, and the larger one is 152. We also have 2 belts to join them to do the driving. Unfortunately, these aren't exactly what I wanted. I did want to use a timing belt style pulley, but I couldn't get them and they weren't available off the shelf, which means we would have had to make them. So we've gone with the next best option, which is a V pulley. And because this is the first time I've ever made one of these, we're not 100% sure whether the ratio of the pulleys is going to be correct to match the motor's RPM and also get the correct amount of torque out of it. Once we do some testing, we may have to change the size of the pulleys. Once we get that dialed in, I'll definitely go to the effort of making up the correct timing belt style pulleys that I need. So what we're going to do now is set up our first pulley in the lathe and drill and ream the bore to 24 mil. And that is to match the motor and the spindle shafts. So first thing I'm going to use is a 23.5 mil drill. Now I'm going to go in with a 24 mil H7 Goering ream. So that's our first pulley done. Now I just need to change out the jaws so we can do our larger one. That's both of our pulleys drilled and reamed. Now we need a broach and a keyway. And to do that, I'm going to be using the lathe. To set up the press would take half an hour of time. These are only aluminium, so the lathe is going to work perfectly. I'm going to be using my 24mm broaching plug and an 8mm keyway broach. So that's our first pulley broached. Now we just need to do the second one. Now with that done, we can test fit them. The pulleys fit those shafts perfectly. Now we're going to set up the spindle so we can see how we're going to mount the guard. Check alignment. So that fits really nicely. We are hard up on the bolt holes, but that means we've got 10 mil of adjustment as the belts wear in and they stretch. So now what we've got to do is tack together the guard and see how we're going to fit it. The material we're using is 1.5 mil sheet. We've had that laser cut and pressed to shape. All we need to do is bend it, tack it in position and weld it out. Because the sheet is only 1.5 mil thick, I'm not going to try and do a continuous weld around the ends because I'm just going to blow holes in it, so I'll just tack it up. Now that's welded, while we wait for that to cool down, we're going to make up the spacer that holds the tool post grinder to the top slide. Because of the motor, we won't be able to use our handle off our quick change tool post, so I am going to put the bolt in and take some measurements. And to make our spacer, I'm going to be using some 65 by 40mm hollow bar. So that fits spot on. Now we can finish off the guard.
Ooh, what you found? Oh, what's this? Spin around. Oh, good boy.
So that guard looks really good on there. I'm really happy with how things are turning out. I do have a few options on how I could mount the guard onto the grinder. I could use some standoffs that get welded onto the base or some bracketry, but I do want to keep this simple and easy to access, so I can remove this and change the belts or change out the spindle. So to mount the guard, all we're going to be doing is drilling and tapping holes into the base and using bolts. So I am just going to use a paint pen, dab it on the end of the bolts, and I'll just hold it in position and transfer the mark that way. So I got those holes drilled and tapped. Now we're going to reassemble the rest of the guard. For now, I'm just going to be using these threaded rods and some nuts to hold the guard in place, but I will be changing them out for some socket head cap screws like I have used on the rest of the project, but I don't actually have the right length in stock. I'm also going to be using some spacer tubes, and they are to keep the guard the correct distance away from the pulleys. So that's bolted on and all of our clearances worked out. We also have enough room around the pulleys to adjust the motor as the belts stretch. So I've just fitted a 1-inch stone to it, and I'm going to spin it by hand just to show you how everything works together. Righto guys, so that is our tool post grinder assembled except for the VFD to power it. So you'll have to stay tuned for the next video where we test this, get it painted and assembled, and give you a demonstration. Thanks for watching. Because I'm more than likely going to blow holes in it, so I'm just going to... Right. Now that that's set up, we're going to find out... Oh, fuck me, I've already fucked up. What I'm going to be using is a Nord 3-phase 3 horsepower. So those Pulleys. So now that's cooled down, we're just going to what'd you say? What'd you say?
Oh. Damn it. Could you have put a smaller hold down bolt? Like, too late. Alright, man. Are you serious? Hey. Come back here.
Righto guys, so that is our tool post grinder. Oh, fuck me. Righto guys, so that is our tool post grinder assembled except for the VFD to power it. Hey,
You said you had it.
I thought I did. Righto guys, so that's our tool post grinder assembled. Oh, stop putting your arms down.
I need to because I'm just getting exhausted listening to this. Quick, it's raining. Wait. Oh, you're such a sook.
It's alright, you're a good boy. You are a good boy. It's raining. Hey, it's raining. Yes, I see you.